Hello everyone, in this video I'll be solving a problem alternating series, and it was asked in Codeforces Round 1042 for division 3. So let's read out the problem. You are given an integer n, call an array A of length n is good if I greater than equals to 1 less than n, A of I into B of I less than 0, that is the product of adjacent elements is negative, and for all subarrays with length at least 2, the sum of all elements in the subarray is positive. Okay, so yeah, additionally we say a good array of length n is better than the good array B of length n if modulus of all the elements is lexicographically smaller than B of I. Okay, note that okay, model of z denotes the absolute value of z. Output a good array of length n such that it is better than every other good array of length n. So basically, in this problem, it is very interesting one, and after this video, you'll be telling like, okay, this was one of the good example. So let me try to explain you on the board. So in this example, what they have asked is they'll give simply n. In first example, n they given is 2. So now your task is to find array, better array. You'll have to find better array. Better array you'll have to find. Let me tell you what is better array and good array also. So array A whose length is 2, that you'll have to find. Okay, so length 2 we'll have to find, and some of the conditions that they have given are for a good array. What they have defined is, first condition is that all the adjacent elements in the A of I into A of I plus 1, it should be less than 0, which means it should be negative elements, which means in array, let's say we have A1, A2, A3 up to so on, AN, middle we have AI. Okay, so whatever elements you have, the product of adjacent elements has to be less than 0, which means one of the element has to be positive, one of the element has to be negative. Only then you will have the product as lesser than 0. If both the elements are positive, then product will be positive. If both the elements are negative, so minus 5 into minus 10, if you do, this is 50, because minus into minus, that is plus. So we have found that the array elements will be positive, negative, and then it will be positive because all the subarrays, I mean all the adjacent elements we have to check. This is one of the adjacent element, this is one of the adjacent element. So now again you have to check negative, but this is not the right one. First it will start with negative. I'll be telling you why it will start with negative, don't worry. So this is one of the condition, and in order to in order that array is good, one more condition is that you'll have to choose subarray. Subarray, I think you guys know, it is a contiguous part of the array. If you take a1, a2, a3 up to ai up to go till an, this is one of the array. So subarray of minimum length 2 you'll have to take. Okay, so you can take a1, a2, you can take a1, a2, a3, because this length is minimum of 2. This is also 3, which is minimum of 2. A1, A2, A3, A4 you can take. Now you can take A2, A3, A2, A3, A4, this like this you can take. And if you try to sum up these values, it should be positive. All the subarray elements has to be positive, that they're saying. Now if you take 2 elements, 3 elements, 4 elements, all this sum has to be positive. So the question looks very tricky, but I'll tell you, it is not that hard. So yeah, this is definition of good array, but there is one more thing, definition of better array. You will have to find the better array, not the good one. Better array, what they're saying is, it is that array wherein modulus of a1, modulus of a2 up to so on, modulus of an, all the elements has to be lexicographically smaller element, meaning let's say 1 2 3, this is the array element A, and 2 1 3, this is the array element B. So A is smaller lexicographically because the first at the ith operation, A element, array of element is lesser than this one is lesser than 2, so it is the lexicographically smaller element. Now let's take this element. So now also this array A is only lexicographically small because these two elements are same, and this is the position wherein there is a mismatch of values. So and it is lesser, so it is a lexicographically smaller element. So better array this you will have to find. So I think you guys got to know problem statement. So how do you find this? When they have given array as n is equal to 2, my idea will be, let me take first element as minus 2, or let me take 2 only and second element as minus 3. If you try to take this way, now one thing you'll have to now check is that the product which is minus 6 lesser than 0 true according to good array definition. The sum of the sum of the values you will find, that is minus 1, and it is greater than 0 which is positive, because you want positive is false. This is true but this is false, so this is not a valid one. So let me try to take positive here and negative here. So now see, if array elements are still negative, minus 2 into plus 3 is minus 6, but your sum of this array is 1 which is greater than 0 which is positive, and this is one of the valid one. But do you think this is the better array? This is good array, that is fine, but it is not a better array, because if you take one more array minus 1 comma 2, your product is minus 2 which is lesser than 0 is true, and your sum is plus 1 which is greater than 0 which is also true. Both the conditions satisfies. But this array, if you take mod of first one, so it is 1, and mod of second one which is 1, and if you try to take mod of this value, so it will be 2 comma 3. So if you see, this is lexicographically smaller element, right? So yeah, this is one of the array. So how do you find that minus 1 you will have to put here and minus 2 you will have to put here? So okay, this comes based on observation. See, one observation is that all the elements, adjacent elements has to be negative. So if it is negative, so alternate elements, adjacent elements have the opposite signs. That is one observation. And why first one negative, why not second one? Because okay, if you try, since you have taken in this example wherein let's say you want to take this one, if you try to take second element as negative, so product will be lesser than 0 only, but summation will be minus 1. Okay, if summation is minus 1, then it is not valid. Okay, now you will tell, okay, don't take of this kind, you take 3 and 2. Now your product is minus 6 and summation is 1, and this is a good array, but you will have to find the better array, right? So better array you have found it, minus 1 comma 2 is the answer. Okay, and because lexicographically, if you see 3 comma 2 is greater than 1 comma 2, so lexicographically smaller you have to find. So that is the reason, whatever element I want to put at the left side index, I want to put the smallest index, smallest number. So I will be inserting here 1. If you want to insert 1 here, then let me derive one more time. I want to give a clear picture how I have thought during contest. So whenever smaller element you want to find, so you are going smaller element 1. Okay, so now you have given smaller element and you want to find the next negative element will be there. So if you put anything, because after 1 if you put anything, that will be 2 or 3 or something like that. But since subarray summation will be negative, so that is the reason I'll be putting minus here. If you want to put minus at first position, then if you put any element at this position, so the subarray sum will be positive and the product will be negative only. And there is one catch. Now let's say n is equal to 3. If n is equal to 3, so next element what will be putting? Let's say if you want to put 2 minus 2, so because since you want to take the product of adjacent elements, so product is negative only. If you want to take sum of all the elements, it will be 0. It should not greater than 0 is false. So you want to put, let's say, 4 now. Okay, So if you put 4, that is fine. But this is not a better array. In order to find better array, you'll have to find the lexicographically smallest element. So this minus 2, whatever you have, try to put minus 1. If I put minus 1 at this position, then I can put 3 here, and it is lexicographically smaller element, right? Because sum of subarray sum starts from 2 elements. So if you try to take its sum is 2, and if you take all the 3 elements, its sum is 1, which is again positive. And now I'll be taking this 3 and minus 1. Now sum is again 2. So every time sum is positive and product is negative only, adjacent element product. So by this, what I have concluded is that now whatever element I'll be putting at the first index will be minus 1, and at alternate position I'll be putting minus 1 only in order to find the better element. Okay, at the alternate positions I'll be putting minus 1, and you want to find the what element that you want to put at the middle. If you try to put 2, this is one of the subarray where answer is positive, which is true. Now if you take these 3, your summation is 0, which is not positive. That's why let me try to increase by 1. If you increase by 1, now your summation is 2, which is positive, and here your summation is 1, which is positive. And since at this position you will have to insert the positive value only, so let me again try to put 2. If I because why I'm putting 2, uh, reason being is that I want to find lexicographically smaller element. If I try to find 1, that is fine, it will be there, but for this subarray your sum will be 0, right? So it is not valid, so I'll be putting, let's say, 2. For this subarray sum is 1, that is valid. But if you take from here to here all the subarrays, so your answer will be uh, what your answer will be 5 minus 2, which is 3, that is fine. But if you try to take one more subarray you have, right, minus 1, 2, minus 1, so here your answer is 0. That's why what from this observation you can take is that whatever element you have, minus 3, I mean minus 1, left and right side, the middle element will always be 3. This is one of the observation. Okay, so it will always be 3 at the middle, because when you are taking this subarray sum, it is 2 only. This subarray sum, it is 2, but if you want to take this entire subarray sum, it will be 1, which is positive. That's why I will start the element with minus 1 starting. I'll leave position and I'll again put minus 1 for everything, and I'll put 3, 3, 3. But there is one catch I'll be telling you, where when n is even and odd. So let me try to deal with that now. Now let's say when n is 4, now we have got first element will be minus 1, second 0th index, first index, second index, third index, because n is 4. So now obviously 3 you will be putting here, because that is satisfying the better array and good array conditions. Now if you try to put minus 3, I mean 3 here also, I think you can make still lexicographically smaller this. Whenever, like I'm trying to say is that element this is even, array length is even, and last element will be positive number, and that positive number can be replaced with 2. Why? Because if you try to take the entire sum from here to here, it is 5 minus 2, which is 3, correct? Since we don't have here minus 1, right? So that's why like if it were minus 1, so it was giving you the 0 result. That's why you're taking 3. But at the end you don't have minus 1, so you can take 2 also, that will hold good. So if you try to take minus 1 and 2, you have 1 as the sum. So I think you guys are getting. So this will be the array will look like something like this. And in order to find the lexicography smallest, you will have to take mod values. And this is your lexicography smallest. When n is 5, what we are trying to find, minus 1 will be starting, you will have to find the middle element. You have minus 1, middle element you will have to find, you will take minus 1. So for 5 elements, 4 index are there. Since left and right side we have minus 1 and minus 1, you will take smallest element, which is 3, and here also you will take 3 only. but in only case wherein we don't have -1 at the end, so we'll take 2. So I think you guys got to know how to solve this. So oh my bad, I think video was at the corner. So first you'll have to take n as only n they'll give, and you'll have to find the array. So first thing first, I'll be taking one vector as answer whose size is n, because n size vector we'll have to find, and for every uh, from the starting index, answer of I will be -1 as I showed on the board, and the next index I'll not put anything there. In the again next index I'll be putting -1, so this will take care of. I think I was getting for 0th index, 2nd index, 4th index, 6th index, you'll be putting -1. So now one thing you'll take index idx, let me take, and which will be -1, because from the end we'll have to put 1 2 and then 3 3 3, and that is valid only if you'll have to find n. If n and 1, which means if it is odd, if n is odd, so if it is odd, so -1 will be at the end, and you'll have to insert 3 only. So this is the last index, so index you'll decrease by -1, so you have at the correct position now, and now you'll run a loop if idx greater than 0, and your answer of idx will be 3, and every time index will be reduced by 2, because in this we have taken care of -1, and in this we are taking care of positive numbers. So when length was odd, when length is even, obviously like the last element will be your 2 only, because we don't have -1 at the end, so your last index will contain 2, and I will decrease index by -2, right, because last index you have taken care of. Last index will be -1, and one more last will be, now you will have to fill it, and there you will be filling at -1, sorry 3. So in index greater than 0, your answer of index will be 3 only, index minus equals to 2, and at the end you will have to print the answer. So that is very easy part, answer of I and L. At the end let's take here you will have to put space separated. So let me try to run the code. Yeah, it is getting passed. Let me try to submit it. Problem name was B. It was alternating series. Let's try to submit the code. So yeah, let's wait. It is running on test 1 and it got accepted. So yeah, thank you guys for watching the video. Like in this way you could have solved it. So basically you had to find the, since -1 we have on left and right side, middle element will be 3 only, and when there is even number of length in a subarray, in an array, so in that case -1 will not come at the end, so in that case you can put 2. So yeah, thank you guys for watching the video, and if you understood, just like it. Thank you guys.